Right, in this video, we're going to be going over the 4 other trig graphs. Because there's 6 trig functions. We've gone over 2 of the graphs. So in this video, we're going to hit the other 4. Okay, so we're going to start out by talking about cosecant. If you remember, cosecant is the reciprocal of sine. So the cosecant of alpha equals 1 over the sine of alpha. All right. Now, what does that look like graphically? Okay. You can probably tell by now the graph in front of you is not the cosecant graph. It is the sine graph. Okay. That is because an easy way to draw the cosecant graph is to draw in a sine graph. Now, before I show you what it looks like, remember cosecant is simply 1 over sine. Okay, well, since this is 1 over 1 is 1, this is -1, 1 over 1 is -1, same thing with these two. But what happens when it crosses the y-axis? What happens when it crosses the x-axis? Okay, well, the answer to that question is you're going to be dividing by 0. What happens when you divide by 0? It blows up. Or in graphic terms, it means you have an asymptote. So your cosecant graph has an asymptote every place that the sine graph crosses the the x-axis. So the blue is your sine, the green is your cosecant. Now what I did do is I did leave out, that's not going to work now because I grouped it. I left out the asymptote for the x-axis, the y-axis. Why am I getting these mixed up today? The y-axis is an asymptote for the cosecant graph. Okay, so at 360, -360, -180, 0, 180, and 360, it has an asymptote. Now, what would the period of this graph be? Take a moment and look at it. All right, the period of this graph would still be 360 degrees or 2 pi, because one cycle of this graph is one parabola pointing up and one parabola pointing down. Okay, so it still takes 2 pi or 360 degrees to repeat one cycle. Okay, so the period is still 360 degrees. Period is still 360 degrees. Okay, make sure you remember that. Now your secant graph. The same thing that holds true for the cosecant graph holds true for the secant graph. Every place the cosine function crosses the x-axis, you have an asymptote. So the green is your secant graph. Again, the period is still 360 degrees because it still takes 360 degrees for the function to repeat. So the period is still 360 degrees. Okay? And again, the easiest way to draw the secant graph is to draw a cosine graph, put in asymptotes at every place where the cosine graph crosses the x-axis, and then simply draw in your parabolas in between those asymptotes. All right, that's the easiest way to draw a secant graph. All right, now the next one we're going to talk about is tangent. Here is your tangent graph. All right, if you remember, your tangent is sine over cosine. So sine of alpha over the cosine of alpha. All right. So it does kind of give you a completely different looking graph than your sine and your cosine. All right. But this is what it looks like. And again, since it is sine divided by cosine, every place your cosine crosses the x-axis, you're going to have an asymptote, just like you did for the secant graph. Okay. Every place it crosses the x-axis, you're going to have an asymptote. All right, so your asymptotes are again at 90 and 270, -90 and -270. But let's figure out the period for this now. How long does it take the period? How long does it take this graph to make one cycle? If you said 180, you are correct. Your period for tangent is 180 degrees or pi radians. Okay. So your tangent graph looks completely different than your sine and cosine. but it kind of behaves similar to your secant graph because it has asymptotes in the same places. All right, it has asymptotes in the same places. Okay. Now let's look at the cotangent graph. Lastly, the cotangent graph is, of course, cosine of alpha over the sine of alpha. So this graph will have an asymptote every place your sine graph crosses the x-axis. And in this case, your sine graph crosses the x-axis at 0, 180, 360, negative 180, and negative 360. And also, if you notice, this one flips over the y-axis. So now they point up on the left and down on the right, whereas tangent pointed down on the left and up on the right. Okay? Now, if I ask you to graph one of these, the easiest way to graph it is to try to take the cotangent and the tangent of 0. If you get a value for if you get a value when you do that, you know that the tangent goes through 0. So if I ask you to graph tangent, take tangent of 0. If it exists, you know that you don't have an asymptote at 0, so your asymptotes will need to be at 90, 270, negative 90, and negative 270. If you don't get a value, then, so that means if you're doing cotangent, you take it, you don't get a value, then you know that your asymptotes are going to be at 0, 180, 360, negative 180, and negative 360. Okay? So that's the easy way to do it. If you can't remember which one has an asymptote at 0, take the tangent or the cotangent of 0. If you get a value, it goes through 0. If it's undefined or does not exist or whatever the calculator says, then you know you have an asymptote there. Okay? Now, let's talk about the amplitude of these four graphs. So here's your cotangent graph again. Here's your tangent graph again. Here's your, well, let me tap on it to bring it back. Here's your secant graph again. And here is your cosecant graph again. Now, hopefully you wrote all four of these down. Let's look at the amplitude. Remember, the amplitude, you can look at it as how far it is above the x-axis. Okay? Well, how far are these above the x-axis? Well, the answer is they go infinitely above the x-axis. Okay? So the amplitude for these graphs does not exist. Okay? These four trig functions, the amplitude does not exist. Now, for cosecant and secant, you can still kind of use the amplitude because then it'll give you how far and below, how far above and how far below it goes above the x and y axis. I mean, above the x-axis, but you can't actually use the amplitude because these go up forever and down forever. So you really, these don't have an amplitude. Okay, and of course, tangent and cotangent don't because they're simply you can look at them as almost as x cubed graphs, and of course they go on forever up and down. Okay, they go to both negative and positive infinity. So these four graphs that we went over today do not have an amplitude. Okay, and the period of secant and cosecant is still 360 degrees, but the period of tangent and cotangent is 180 degrees or pi radians. Okay, so make sure you wrote these down, commit these things to memory, and I will see you tomorrow in class.